So in the last video, we were working on switching back and forth between two LED lights so that we could have them on at the same time. And you can see here I've got our Arduino program running, and what I've done is I've got one LED that's on at red and the other LED is blue, and just switching back and forth between those two, turning them on and off as quickly as Arduino can do it. And it's so fast that it looks like they're both on all the time to us. Now that's great when we're using just pure colors red and blue, but if I now change and I want to do orange on one and maybe like a purple on the other, I'm just going to reduce the blue here a little bit. So I'm now on the first LED, I'm turning it on orange, and the other one should be purple. So let's go ahead and upload that and see what happens. And it's going to go through our startup sequence that we've already programmed, showing that we can create all the colors, and then we should see orange in one and purple in the other. And as you can see, now we kind of have a problem. Both of them are sort of flickering. And so we've got to fix this problem because that's not going to look good in our display. So let's figure out what's going on. So let's talk again a little bit about what PWM pulse width modulation frequency on the Arduino is doing, and that'll help us understand why we get this flickering going on our LEDs when we're trying to switch back and forth between two LEDs and have colors that are something other than just red, green, and blue. So what's PWM really doing? Let's take a little more in-depth look at what's going on. So pulse width modulation output, anytime we're using a digital pin on the Arduino to simulate an analog pin, we're using pulse width modulation. And what's going on is it's actually outputting a square wave. So it's high for some of the time and it's low for some of the time. And so we approximate an analog signal on these digital pins by using PWM, and we use the command analog write. So here's an example, analog write, and I'm telling it to go write that to some pin that I've called pin, and its value is 128. So it should be half on half the time and off half the time. Values for the analog write can be 0 to 255. So what's really happening here is that the Arduino is comparing the pulse width modulation, or the PWM value that we gave it in the analog write command, to an internal 8-bit counter. So an 8-bit counter basically is just a binary counter that counts in binary from 0 to 255. So what happens is it's if the counter in this internal counter or timer is less than the PWM value that we gave it, then the output for the pin is set high, and if it's greater than or equal to the PWM value, then the output's low. So you can see kind of here up in the corner that I have a diagram of a square wave and this frequency of the wave. So how many waves, how many cycles per second of the PWM, it depends on how fast this counter is. So if the counter is going through its 8-bit counting really quickly, then I'm going to have a faster cycle there. I'll have more cycles per second. So if it's 0, from 0 it's high up until I get less than 128. And then at 128 it switches to low, and then it's low until 255, and once the counter resets to 0 it goes high again, and so it just keeps doing that over and over again, so we get this continuous square wave. So the reason that we're getting this flickering is basically because we have timing problems, and those stem from the frequency of our PWM. So let's figure out what's going on. I timed the loop, the time that it takes loop to run, and that's just our switching on and off of each of the two LEDs. And it takes about 0.12 milliseconds to run. The frequency of the pulse width modulation is set at a default of 490 hertz. That means 490 of those waves per second. So we can invert that and figure out how long each cycle takes. So if I take 1 over 490.2, it gives me about 2 milliseconds. So let's take a look at an example. If I want to do orange, that means I need red at 255, that means red's on all the time, and then green at 165. So green would be on for part of that PWM cycle and then off for part of it. So let's take a look at what the timing diagram looks like. So here I have a timing diagram. The red line indicates that I've got red, the red part of the LED on all the time, and then the green is showing that green is on for that percentage of the time that it takes to count to up to 164, and then at 165 it switches to off. So let's see what is happening as we're switching on. So the arrows are indicating that's a command each time it runs the loop for the light to turn on. And you can see that at some parts of the loop the light turns on and it's red and green, and then in some parts of the loop the light turns on and it's just red. And so we can see this kind of flickering thing happening. So what we want to do is make this PWM wave faster than how fast the loop runs, so we can play with the timing of it. So what we need to do is speed up that PWM wave. The PWM has a timer, and its clock is equal to the system clock divided by some prescaler value. So the system clock is the clock that the microchip is running at, and then we have this timer clock that we can use to time things. And there are 3 clocks or 3 timers inside the Arduino, and they're represented by a code TCR 0B for the 0th timer, 1B for the timer 1, and 2B for timer 2. They control the frequency of each timer controls the frequency of 2 different pins. The 0 timer controls the frequency of 6 and 5 pins. The 1 timer controls the frequency for pins 9 and 10, and the 2 timer controls the frequencies for pins 11 and 3. Since we're using 9, 10, and 11 for red, green, and blue, we need to set those 2 timers. And the code that we need to put into setup in order to set that timer divisor to 1 instead of what it was for the default, that'll give us a frequency of over 31,000 hertz, which will be way faster than the 490 hertz. So this is the command. It's basically the coding you don't need to worry about unless you want to investigate on your own what that is, but basically it's clearing that pre-divisor, that pre-scalar value, and it's setting it to 1 so that we're dividing it by 1. And then at this frequency, the pulse width modulation is only going to take about 0.03 milliseconds, which is much faster than the 0.12 milliseconds that it takes to run loop. So this should fix our issue with the flickering that we're seeing. Okay, so we're going to fix now the blinking problem by changing the timers in the Arduino for the 2 pulse width modulation, the 3 pulse width modulations pins that we're using. So I've put the little balloons, paper balloons, back onto the LEDs so you can kind of see the flickering maybe a little bit better. And now I'm going to go scroll up to the setup. So here's our setup function, and I've already written in the code for changing each of the timers. So here's changing timer 1 to set the divisor to 1 so we get a faster frequency, and then the same command for timer 2. So I'm going to go ahead and upload that, and we'll see if we can get that fixed. So it's going to again run through the setup code of the fading in and out. And now we get kind of a bluish purple and a yellowish orange, but there's no more flickering. And I can take off the little balloon so you can see these lights are on and they're on steady because we've sped up that pulse width modulation wave. It's happening so much faster that we're not seeing any blinking anymore. So now you can say, well, the colors don't look exactly how I'd like them to look, and you can play with now the values here where we have custom values and change those to get the color that you like, and then balance using resistors to get the right balance that you want. So for example, if I'm, this is supposed to be orange, maybe it's a little too green, so I can reduce this green value until I get the orange value that I like, the color of orange that I like. And by doing so, if I need to reduce that, that means that I need a higher resistor on the green to get the right color. Same thing with the blue and red. I reduced the blue here to get a color that I thought looked more like purple, and that means that I probably would like a higher resistor on the blue LED, and that's just largely because that blue LED has higher lumens. So you can play with the resistors with different values, or your instructor will give you the resistors that they would like you to use to get the right color values that you're looking for. So we should be ready now to start tackling the main electrical engineering project, and those will be explained in the next videos.